In this video, I'll be working out some of the homework answers to the Chapter 7, Day 9 worksheet. And we're talking about exponential decay, specifically radioactive decay. So number 1 says iodine-131 is a radioactive material that decays according to this equation where A sub 0 is the initial amount. They want to know for part A, what is the half-life? So whenever you are talking about half-life, you're taking half of the original amount, and you want to know how long it's going to take to decay down to that original amount. So it's 1/2 A sub 0 is equal to the formula that they gave us. And since A sub 0 is the same on both sides, it's 1/2 is equal to E to the negative 0.087 t power. We know to take the natural log on both sides. And then I'm going to move that power out front. The natural log of E is just 1. So then the time is the natural log of 1/2 divided by negative 0.087, which is around 7.97 days. 7.97 days. So then part B says how long does it take for 100 grams to decay down to 20? So make sure you put the 20 out front because the 100 is the initial amount. So we're starting at 100. How long does it take to go down to 20? Very similar problem here. Right? You're going to divide by 100 and then you're going to solve for t. And then for number 1 part C, it says how long does it take 100 grams to decay down to 10? So very similar work here as well. All three of these problems are just going to use the fact that you have to divide by 100 and then take the natural log on both sides. For part B, it should be around 18.5 days. And for part C, 26.47 days, or around that, depending on how you rounded. So reach out to me if you can't get those two numbers. I'd be more than happy to help you out. But I'm going to flip here to the back. I'm going to go to the very, very last problem, number 3. It says the half-life of radium is 1,690 years. Answer the following questions. First off, find the value of K. So they're talking about this. Right? All they gave us was the time, but that time is relevant to the half-life. So I'm going to write the following. So I'm going to solve for K. By taking the natural log on both sides. So the K value is the natural log of 1/2 divided by 1,690. This is going to be a very small decimal, negative 0.00041. And so it says if 10 grams are present now, how many will be present in 100 years? So this would be 10 grams are present now. How many are present in 100 years? You don't have to take the natural log on this problem. You can just type this into your calculator, and it's going to come out to about 9.6 grams. There's your quick video.